All right, so today we're looking at a piece of hardware with, well, it's got a wildly unsexy name.
It's a mouthful, yeah.
The NTI HD4K18GB-FO-50M-MM.
Right.
I mean, it's a 50-meter HDMI cable.
Right.
But the thing that just, immediately jumps out isn't the model number.
It's the price.
It's the price tag, $270.
Which is pretty steep if you're used to grabbing a $5 cord at the store.
Exactly. So our whole mission for this deep dive is to figure out, why? What does $270 buy you?
What does it do that a standard cable doesn't?
Right. Because 50 meters.
Yeah.
That's about 164 feet.
Hmm.
If I tried to push a 4K signal that far on a normal copper cable, I'm pretty sure I'd just get nothing.
You'd get snow. Yeah. Or more likely just a black screen. It's a straight-up physics problem, really.
Okay.
Copper wire has resistance, and over those long distances, the electrical signal just degrades. It basically runs out of steam before it even gets to the display.
And that's where the FO in that ridiculously long name comes in, I'm guessing. Fiber optic.
That's it. This isn't just copper. It's what we call a hybrid cable.
A hybrid.
Yeah, it combines copper conductors for the low-speed control signals with these fiber optic cores for all the heavy lifting, the actual video data.
Oh, okay. So instead of just pushing electricity down a super long wire, it's actually converting the signal into light.
That's exactly it. Inside the connector heads, you've got these tiny little transceivers. Mm-hmm. The source end turns that HDMI signal into pulses of light, fires it down the glass fiber with basically zero loss, and then the other end just converts it right back.
Which solves the distance problem, but I assume it also solves the whole interference issue. Copper is like a giant antenna.
A huge antenna for any kind of electromagnetic noise. Yeah. If you run a long copper cable near, power lines or even fluorescent lights, you're going to get noise.
Little sparkles on the screen?
Sparkles, or the signal just drops entirely. Fiber is, well, it's totally immune to that. It's just glass. You could run this thing right next to an MRI machine or through an airplane fuselage, and that signal stays absolutely pristine.
Which makes perfect sense why the source material points to things like medical imaging and digital signage.
You can't have a surgeon's monitor glitching out?
No, not because someone turned on a microwave next door. So beyond just reliability, you're really paying for the bandwidth.
You are. This cable is rated for 18 gigabits per second.
Okay, so that's the magic number for full Ultra HD 4K at 60 frames a second. But looking at the specs, the really big deal seems to be about the color. It supports 4.4.4 chroma subsampling.
And that is crucial.
So for anyone who doesn't know, that basically means it's not like compressing the color information at all, right?
Correct. Most video you stream, it compresses color to save bandwidth. And that's fine for watching a movie.
Yeah, you wouldn't notice.
You wouldn't. But if you're using this for, say, a computer monitor or a flight simulator, you absolutely need 4.4.4. Without it, fine text can look kind of blurry.
Well, you get that weird color fringing on sharp lines.
Exactly. So you need that huge 18 gigabit pipe to fit that raw, uncompressed image, plus all the heavy audio data like Dolby True HD.
Okay, now wait a minute. Usually with these active cables, the ones with converters inside, you have to plug them into a wall outlet. They need power.
They do.
But this one doesn't have a power brick.
Nope. It's a really clean design. It uses what's called parasitic power.
Parasitic?
Yeah, it just sips the 5 volts it needs directly from the HDMI port on your source device, specifically from pin 18.
That's pretty clever, as long as your source has enough juice.
Well, you need about 500 milliamps, but pretty much any modern source can deliver that easily. So you get all the benefits of an active system, but it installs like a simple plug-and-play cable.
And speaking of installation, the other thing that jumps out is just how it's built. It's only 4.5 millimeters thick.
Which is tiny. That's the fiber advantage again. It doesn't need all that thick rubber shielding that copper needs to have.
Right.
It's got a bend radius of just under 2 inches.
And if you've ever tried to pull one of those thick shielded copper cables through a wall or around a tight corner, it's a total nightmare.
Oh, they're so stiff.
Yeah, this sounds more like routing a phone charging cable.
I mean, it's the difference between dragging a garden hose and a piece of fishing line through the wall.
So when it comes down to it, this is a pro-grade solution. If you absolutely need to send a perfect, uncompressed 4K signal across a huge space, a lecture hall, a home theater, whatever, This is the kind of do it once and just forget about it tool.
Yeah, it's for when good enough is definitely not an option.
You know, it's a good reminder about the invisible infrastructure that we all rely on.
Totally.
We spend all this time and money researching the perfect screen, the best TV,
Obsessing over the destination.
but we barely think about the pipeline, the cable that's actually delivering the entire experience.
We totally ignore the road until there's a pothole in it. But look, if the connection is bad, it really doesn't matter how amazing the destination is, does it?
Something to think about before you just grab the cheapest cable on the rack. Thanks for listening to this deep dive.